Hi friends, we often come across the word transfer of weight. So let us understand what is this transfer of weight. So you can see this vehicle, a four-wheeler with drive elements like engine, transmission. Transmission consists of propeller shaft, then universal joints and slip joint, and then you are of course clutch and gearbox. So this gearbox is nothing but your transmission, and drive shaft is nothing but your propeller shaft, and of course in the rear wheel you have a differential to make it allow to inner wheels and outer wheels rotate at different speeds. So now let us see what is this transfer of weight. Actually, the effect of applying brakes on a moving vehicle is to cause transfer of its weight from the rear axle to the front axle. So if you are braking, so in the front, so definitely some weight of your rear axle is going to be transferred to the front axle, right? So now the question comes naturally, what is the percentage of this weight transfer? So let us see that. The percentage of the weight transfer increases with increase in the intensity of braking. The more you brake, the more the percentage of weight transfer from rear axle to the front axle, right? So that's the meaning of this. And now this is the reason the passengers are pushed forward in a bus while the brakes are applied. So this is the reason. So the weight transfer is the reason behind the passengers being pushed forward in a bus while the brakes are applied. Now let us see. The braking effect on the front wheels should be greater than the rear wheels. So definitely it hints at the point that the braking effect on the front wheel should be greater than the rear wheels. Why? Actually, some part of the weight of the your rear axle is being transferred to the front axle. So that's the reason you have to. That means the braking effect should be more at the front wheels than your rear wheels due to this transfer of weight. No. What are the figures actual figures? So what are the actual figures of transfer of weight or braking effect and all these things we'll see. So now for achieving maximum efficiency, about 75% of the total braking effect on the front wheels. So to achieve the condition of maximum efficiency or to obtain maximum efficiency, the amount of the percentage, in fact the percentage of the total braking effect should be 75, but it is not so in actual practice. So what is the reason behind that? So however, in practice it is not possible due to the possibility of skidding of front wheels on wet roads. So you assume that your vehicle is moving on a wet road, so definitely it is slippery and it is going to skid. So if the more braking you apply, the more chance of skidding it will be there. So now there is a reason behind this, the limit on the amount of transfer of weight, right, or braking effect. So now however in practice it is not possible due to possibility of skidding of front wheels on wet roads. On wet roads there is every possibility of skidding on the road, right? So that is the reason it is not possible. Actually that 75% of the total braking effect. Okay, so for example you are applying 100 newtons, you should not apply 75 newtons. So around 60 newtons only to be applied. So that's what we see. So now about 60% of the braking effort is applied on the front wheels. So because of this reason of the possibility of skidding of front wheels on wet roads, on slippery roads, so actually only 60% of the braking effort is only applied on the front wheels. That is the reason behind. So this is about your transfer of weight and also the amount of braking effort normally that should be applied on the front wheels. So let us meet in a next video shortly, and good subject video. All the best.